Hello everyone, this is Dr. Lennon, and today we are going to talk about the quadratic formula. So, the quadratic formula is the general way to solve any quadratic equation. So, remember what a quadratic equation looks like. Oh, sorry, I keep hitting the wrong button. Any quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. So we looked at solving those by factoring, but factoring won't solve every type of quadratic. For instance, if we look at, say, I don't know, something like x squared plus 13x plus 10 equals 0, this won't have any solutions because there's no way to factor 10 into two numbers that add up to 13. Remember, that's the only way where you're going to find a factorization. So for instance, the only possible factors of 10, so we could make that chart, factors of 10 and their possible sum. Well, there's only a few options. You could have 1 and 10. Those add up to 11. You could have -1 and -10, which adds up to -11. And then the only possibilities are the prime factorizations, 2 and 5, which here adds up to 7, and -2 and -5, which adds up to -7. So in our list of numbers, 11, -11, 7, and -7, 13 doesn't appear. So there's no factorization that's going to allow us to solve x squared plus 13x plus 10 equals 0. So there's a formula that allows us to do that. So first what I'll do is I'll show you where that comes from. So we're not going to do a full proof of the quadratic formula, but the idea of the proof comes from what's known as completing the square. And it's a pretty neat idea. And the reason is you can take any quadratic that you can set to a perfect square. We know how to solve it, right? Like if we were somehow able to get something like x minus 5, something like that squared equals, let's say, I don't know, 64, then we could actually solve this equation, because that would mean x minus 5 has either got to be -8 or x minus 5 equals +8. Why is that? Well, basically we can say x minus 5 has got to be plus or minus the square root of 64, and the square root of 64 is 8. And then we could solve each of these resulting linear equations by just adding 5 to all parts. And we would see that x would either be -3 from this equation, or from the second equation, x would be 8 plus 5, which is 13. So -3 or 13 would be the answers to that quadratic. But the problem is, how can we take a quadratic and write it in such a way where we can get a perfect square equation like this? Well, that's the idea of completing the square. Okay, so let's look at what that means. So basically our goal is, can we take a general equation and break it down into a binomial square, like the left-hand side, x minus 5 squared, equals a constant value. So completing the square is that idea. So basically the way it works is, if you consider the expression x squared plus bx, then we can transform it into a perfect square by adding, kind of almost looks like a thing you would never guess, but b over 2 quantity squared. Okay? And you can notice that because, so basically what I'm saying is, if you have x squared plus bx plus this b over 2 quantity squared number, I claim that this actually factors into x plus b over 2 times x plus b over 2 which is in fact x plus b over 2 quantity squared. Okay, so just to see that that's true, to check that that actually works, you could take x plus b over 2 times x plus b over 2 and FOIL it out to make sure that it does in fact simplify to x squared plus bx plus b over 2 squared. So if you multiply out, you can just use FOIL. So x times x is x squared. Your outside term x times b over 2 is plus b over 2 times x. Your inside term is also b over 2 times x. And then your last term would be b over 2 times b over 2, which is b over 2 squared. The middle terms, notice they're like terms because they're x terms. You have two of those, so this is actually x squared plus 2 times b over 2 x plus b over 2 quantity squared. So this is actually just x squared plus bx plus b over 2 squared. So that does in fact give a perfect square binomial. So, how would you come up with this? Well, maybe you just look at a bunch of perfect squares and notice that there was kind of a pattern there, and then write this in a general way. Now, why is this useful? Well, we can take this idea and leverage it into a way to solve equations. I won't require you to do it in the future on any quizzes or tests. You can just use the quadratic formula, but this is the idea. If you would do this every time, this is where the formula comes from. And the formula essentially just gives us a shortcut method to solve all of these quadratic equations. Okay, so let's look at an example. So let's say we want to solve x squared minus 8x plus 13 equals 0. Well, the first step, and we can even say by completing the square, let's say. So, how does this work? Well, basically we need to get all the x terms on one side of the equation and all the numbers that don't have an x on the other side. So we can start by subtracting 13. So this turns into x squared minus 8x equals negative 13. And then this is the part where we add that special number to both sides. So that number was b over 2 squared. So b is the coefficient of x, which in this case is negative 8. So this is x squared minus 8x, and we're going to add that number to both sides. So we're going to be adding negative 8 divided by 2 squared to both sides. And you could simplify it first. I'm just leaving it that way so you can see that it looks like a b over 2. So this is going to be negative 13 plus negative 8 over 2 quantity squared. So negative 8 over 2 is actually negative 4, and negative 4 squared is 16. So really this is x squared minus 8x plus 16, and that'll equal negative 13 plus 16. All right? So how does the factorization work? Well, that negative 8 over 2 is negative 4. So negative 4 times negative 4 makes 16, and negative 4 plus negative 4 makes negative 8. So the left-hand side factors to x minus 4 quantity squared, and the right-hand side just becomes positive 3. 16 minus 13 is positive 3. So at this point, we can use the square root principle that says, okay, well, if you do the square root x minus 4, well, that's either got to be plus or minus the square root of 3. Okay, so usually they'll use this notation plus or minus as kind of shorthand for both answers. So we can solve the equation by just adding 4 to both sides. So essentially this becomes x is equal to 4 plus or minus the square root of 3. And that is really just giving two answers, right? So our solution set here, you might say, is 4 minus the square root of 3, comma 4 plus the square root of 3. But remember, on my exams in this class, typically we're going to be allowed to use some decimal approximations since we're mostly focused on the applied side of things. So, I mean, if you wanted to do a decimal approximation, you could do that in the old calculator. 4 minus the square root of 3 comes out to about 2.27 if we round to two places. which means the other one is going to come out to 5.73. So those would be approximately your two solutions to that equation, and good luck trying to factor it. It's not one that you can easily factor. So let's do one more example with completing the square, and then we'll move on to the second part of the video, which will be the quadratic formula. And I may have to film that in a separate link because my maximum time on this screen recording software is 15 minutes. Okay, so let's say solve x squared plus 12x plus 6 equals 0 by the same method. So again, the first step is to move the 6 to the other side, so subtract 6. So we have x squared plus 12x equals negative 6. So the number we want to add is 12 over 2 squared, so x squared plus 12x plus 12 over 2 squared, which is going to be negative 6 plus 12 over 2 quantity squared. So this is x squared plus 12x plus 36, and that equals negative 6 plus 36, or just 30. So how are we going to factor that? Well, 6 times 6 makes 36, and 6 plus 6 is 12. So from factoring, you should realize this is x plus 6 times x plus 6, or x plus 6 quantity squared, and that'll equal 30. Then we use the square root principle on both sides, so we get x plus 6 has to equal plus or minus the square root of 30, and then we could subtract 6 from both sides. So normally the way you write that is just the regular number in front, so x would be negative 6 plus or minus the square root of 30. So your solution set here would be negative 6 minus the square root of 30. The one you subtract is always going to be the smaller value, or 6 plus the square root of 30. And again, we could use decimal approximations for both. Negative 6 minus the square root of 30 comes out to negative 11.48 if we round it 2 places. And the larger value, 6 plus the square root of 30, comes out to positive 11.48. Oh, that's a mistake. I'm sorry. This should be negative 6 plus the square root of 30. So that is my mistake. So that is not the correct value. Or no, this tool. There we go. All right, so negative 6 plus the square root of 30 comes out to negative 0.52. Sorry, wrong color there. Negative. There we go. Negative 0.52. Okay, and that is it for the method of completing the square. So on the next video, what we'll do is we'll actually look at what the quadratic formula is, and we can write that down here. But basically, it's just plug and chug. So the quadratic formula basically says if you have, let's say, ax squared plus bx plus c equals 0, its solutions. So this has solutions given by x equals negative b plus or minus the square root of b squared minus 4ac, with everything being divided by 2 times a. So usually you just identify the numbers, plug them in, do the arithmetic. So in the next video we will come back and look at a couple of examples to do that. So thanks for watching. This is Dr. Lennon signing off.